Welcome, welcome. Good to have you all here. We're switching to a speaker view, and yeah, everyone's trickling in. I'm going to start this webinar immediately. So yeah, again, welcome, all these Zoom faces, all these Zoom names. I hope you pop up on your videos a little bit later. For now, you can kind of listen like it's a podcast. But we're all gathered here today for one overarching purpose, and that's to work towards a nature positive future. This is NTC Now. It's one of the gatherings of the Nature Tech Collective. We're a coalition of organizations that are working relentlessly across categories towards this nature positive future. Our members are on the ground restoring degrading ecosystems, or they're developing cutting edge technology, or they're creating powerful visualizations from all the data of this technology, or they're channeling critical resources where they're needed the most. And all together, we're bridging the gap between innovation and impact to accelerate kind of nature-based solutions at scale. I'm Paige, by the way. I'm the head of the community at the Nature Tech Collective, and each week, or actually twice a month, we bring together experts like Jessie and Jonathan who are harnessing technology to regenerate our natural world. Throughout the NTC Now's content arc this year, we've been exploring how nature tech solutions are implemented and scaled in the real world. And today, we're diving into a case study of marine conservation and blue carbon innovation through the lens of a pioneering business model, uh, Brightwater's pilot project at Turneffe Atoll in Belize. It's demonstrating how a collective approach can unlock new pathways for protecting and valuing coastal ecosystems. This session is going to explore several themes: building trust and partnership with local communities and government, the challenges and opportunities of developing blue carbon projects, or how scientific and technical rigor is applied to measure and verify impact, but also the financial models that support high integrity blue carbon credits, or how co-development with stakeholders is important to create lasting benefits for both people and nature. So I'm so delighted to welcome Jessie Stenftenagel and Jonathan Shibley. I'm so sorry. You told me 2 seconds ago. Shibley. They've both been instrumental in building this project, and they're going to tell you how they've been collaborating. Both of you, thank you so much for joining us today. Could you both introduce yourselves briefly, you and your organization? We're going to be talking for about 45 minutes before we go to an audience Q&A. So maybe Jessie, you can start.
Sure. Thanks so much, Paige. Thanks for having us today. My name is Jessie Stenftenagel. I am the CEO and co-founder of Brightwater. I am a biologist, marine biologist by trade. My history really started with NOAA, where I had a focus on marine mammal behavior, health, and migratory patterns along the East Coast. Had the chance to work internationally in several countries, which specifically Belize, which is one of the reasons that we came up with this idea and interest in developing Brightwater, which is focused on developing high quality blue carbon projects.
Thanks, Jessie. I'm Jonathan Shibley. I work for Stantec. We are a multinational consulting and engineering firm, and I sit in Lexington, Kentucky. I am a wetland scientist and a water resources engineer, one of the engineering discipline leads across our nature-based systems practice, and I serve as the blue carbon expert on our nature-based carbon solutions team, which looks to do conservation and restoration projects specifically for climate adaptation and mitigation.
Lovely. Thank you both. Okay, so Jessie, perhaps you can start us more about kind of Brightwater, what it's building, and specifically this Turneffe Atoll pilot study in Belize. What makes this project unique, for example?
Sure. So I talked a little bit about working in Belize. I have a history there. I've spent really over the last 30 years, quite a bit of time either living and working in the country, which is where this inspiration for the Turneffe Atoll pilot study began. Brightwater has projects in Belize currently. The pilot study is the one that really got us started in the country and started the relationship with the Belize government, along with several other stakeholders, which we'll talk a little bit about. To begin with, I think Turneffe is a very special place if you're not familiar with it, or even Belize. Turneffe is the largest and most biodiverse atoll in the Caribbean. It's home to extensive seagrass beds, mangroves, and coral reefs, and supports many vulnerable and iconic species. It's an atoll off the coast of Belize City, which is up in the northern portion of Belize. It's a major destination for marine tourism. It's renowned for activities like diving, snorkeling, flats fishing, but it also supports productive commercial fishing industry. This diverse marine ecosystem is incredibly important to the country. Its status as a marine protected area contributes to its economic value and sustainable development. It contributes significantly, averaging 62 million per year to the Belize economy, approximately 38 million of which is actually related to the protection from hurricanes for mainland Belize. To date, there's really been some excellent research conducted on blue carbon environments in the country of Belize. I definitely want to mention that. It's what allowed us to really build this pilot study with the government. What makes this project unique is that it really goes beyond the research. We're taking it all the way through to verification and the development of high quality blue carbon credits, which makes it the first initiative of its kind. And we're really trying to set a new precedent nationally.
Amazing, Jessie. Thank you so much for that context. And I'm just remembering, completely unrelated and not even kidding, that one of my best friends just proposed to his girlfriend at this atoll like just 2 weeks ago. So
oh wow,
beautiful enough for those kind of events to happen too.
Yeah.
So Jessie, tell us more about your history with Belize and the relationships that were key to getting this started.
Absolutely. I think trust is really a theme that runs throughout when it comes to the Brightwater Belize partnership. As I mentioned, I've been working there. I've lived there on and off since 2005. I've built strong, trusted relationships with community leaders, government partners, and conservation groups throughout those years. And I really think that it's those long-standing connections that allowed us to create this foundation of trust, which made it possible to start the exploration for a blue carbon opportunity on Turneffe. Some of the early supporters included the Ministry of the Blue Economy, CASA, who is the local monitoring team, who we'll talk a bit about today, very important, along with other scientific advisors who really understood both the ecological and social dimensions of this work. I also think it's really important to note that in our early conversations with the country, we didn't come in with the attitude that we knew everything. Our approach really resonated, I think, with the government because we did prioritize building trust. We didn't arrive with all of the answers. Instead, we expressed a clear intent to listen and learn from their leadership and all of the great work that's already been done in country in partnership with local communities and stakeholders. I think that spirit of collaboration really resonated with them, and it allowed us to align the important work that was already underway and build on what's happening on the ground currently and not reinvent the wheel, which we knew wasn't necessary.
Yeah, so interesting. And so what motivated them to kind of pursue blue carbon projects in general? Or how did you align the goals of your project with their national priorities?
So along with their NDC commitments, they've also just in general been a leader in marine conservation, saw the blue carbon opportunity as one that could help them to secure new financing mechanisms, but also reinforce their existing commitment to protect these very important marine ecosystems. I think our goals aligned closely with their ambitions for sustainable development, equity, and also their focus on ocean-based climate solutions, which is a big theme for not only Belize, as you know, but coastal communities around the globe. So we worked really closely with the government agencies from day one to ensure that this project was going to support national strategies, but again, also include their NDCs and their blue economy roadmap that they were building.
Mm. And you spoke a tiny bit about the scientific uncertainty that exists in blue carbon measurement in general. How are you addressing that in particular?
Jonathan, do you want to take that one?
Sure. So this will be a recurring theme when we talk about things. Blue carbon ecosystems are incredibly dynamic. There's a lot of complicated geomorphology going on. The biogeochemical cycling is very complicated, and it's a lot of moving parts. So there's a lot of spatial variability, and that varies across scales as well. And that can have impacts on project feasibility and your carbon credit yields. And there's really a couple of ways that you can sort of mitigate that. One would be to take a ton of measurements, which can be time consuming and very expensive to try to constrain that variability. The other thing you can do would be to make a lot of conservative assumptions, which also can directly affect the credit yield for your project. So really, what we try to do is be conservative, but not overly so, and sort of address gaps when we see them. And so sometimes that is if we have a really robust body of literature, we can lean on that. Sometimes it is a field sampling protocol. And really with that, we're looking to various and sundry bits of technology to try to, make that as efficient as possible. Remote sensing is one of the things we're really starting to lean into to do that. And then we can couple that with well-established carbon models, and then of course validated ground truth data, and that can really sort of help to get a handle on where those critical uncertainties are, and then how to constrain them better. So it's a bit of technical, it's a bit of practical, and just trying to find what fits the project best.
Okay, amazing. And quite a technical answer. So let's actually take a kind of a step back. Obviously, to start, right, you have to do an initial assessment of the landscape.
Correct.
Can you walk us through that kind of like boots on the ground approach?
Yeah, for sure.
That's the wording, right?
So no, that's perfect. That's exactly right. Although this one is more sort of like waders on the ground, because we are talking coastal wetlands. But yeah, this actually was a little less technical, and it was more outreach when we were on the ground there. So as I was just alluding to, and as Jessie said earlier, there's an enormous body of literature on Turneffe. And there's a lot of recent publications that have very high resolution mapping of both mangrove and seagrass habitat extents. There's a lot of recent carbon density measurements that have been done in country for mangroves for their nationally determined contribution, led by Hannah Morissette from the Smithsonian. And then Stacy Felgate has been doing a lot of work on seagrasses specifically. So we have enough data in hand already to do preliminary sequestration and carbon yield estimates just from desktop. But being there, that was invaluable. We were there last August. When we were on site, we toured the atoll with stakeholders, including the Turneffe Atoll Trust, TASA, which that stands for the Turneffe Atoll Sustainability Association. As Jessie said, they're responsible for the management, patrolling the atoll, and enforcing fishing regulations. We had some local fishermen on board. And this was really a unique opportunity to get local viewpoints about, threats to the atoll, the environmental stressors, the value beyond blue carbon. And we really got a feel for expectations and the support and sometimes healthy skepticism for potential projects and our approach. And so I think that was instructive to us on how we would go about implementing and developing projects, but it's also critical for building this trust that we're talking about with our team and our intent down on the atoll.
Fascinating. And so that's the initial assessment. And from my limited understanding, after that, there's kind of like a feasibility stage, right?
Mm-hmm.
what's determining the factors saying, for you that Turneffe Atoll was suitable for a blue carbon project, apart from
Yeah,
all of that data?
yep. And that was one of the things, Belize has a lot of blue carbon ecosystem area and a lot of it's high quality. And so picking where to go, it can be a bit of a hurdle even. It's almost an embarrassment of resources. But Turneffe stood out for a few reasons. One, we have really high quality blue carbon ecosystems that are facing threats. There are some protections in place, but there are threats from development, fishing disturbance, storms, sea level rise, increasing sea temperatures. Um, so there's one, but those are sort of common themes in country and in the broader Caribbean. But its location and the adjacency to the Mesoamerican Barrier Reef adds huge potential for other co-benefits. So biodiversity, coastal resilience, fisheries, the list goes on. And then again, the studies that I mentioned, a lot of them focused on Turneffe first before expanding out to the country. So that's a bit of the draw. But I think one of the biggest things is one, it's a high visibility project. It's an extremely valuable resource. And then two, a lot of the infrastructure that is going to be needed for long-term management and maintenance of any project out there is already in place via TASA.
And are there any red flags that help you see what not to choose or
Um,
where not to
yeah, I
go?
mean, it's really more on the technical side. Some of the issues out here are involved in land use, and that's probably the biggest complication. There's not really red flags per se, but there are complications.
Okay.
So there's a mix of land tenure, land control, and ownership out there. And so there are parcels that are fully owned and controlled by the government of Belize. There's ones that are leased from Belize, and there's ones that are privately held. And so navigating that led a little bit into the feasibility, and so it really just sort of informed where development was planned, where dredging might occur, or clearing of mangroves. So that was on the impact side. So we tend to look for those projects where we really have a defined, quantifiable risk. And then when we're thinking about prioritizing the potential projects we identified, um, we need to start thinking about landowner incentives, benefit sharing, costs for acquisition of land, and things like that. So really, what this all led us to was that land that is fully owned and controlled by the government of Belize is probably the easiest lift for implementation. Those are the low-hanging fruit that we are recommending going after first. And then, there are ongoing discussions with the government and landowners about what those incentive and benefit sharing programs are going to look like.
Fair. And one of our favorite questions in the Nature Tech Collective is, what technologies are you using to assess and monitor the project site? Um,
Uh,
and how
the,
do you
the,
balance the cost
right.
of all of that with the precision that you need for high quality credits?
Exactly. So, and this is an area of particular interest for me, so I will try to condense
Hmm.
as much as I can. I'm one of the leads on Stantec's nature-based technology and an innovation initiative. And you're spot on, Paige, that, what we found is that the measurement, reporting, and verification, I'm going to call MRV. And one thing, this world is just rife with jargon, and if there are anything that pops up that folks need, just give me a thumbs up or something, and we can stop and explain an acronym or whatever. So MRV is pretty significant cost. Again, that's related to the uncertainty in numbers. The more uncertainty, you have to sample more to try to constrain that, so you don't take deductions in your credit yield based on uncertainty, because defensibility is one of the keystones of carbon crediting. Um, so again, particularly blue carbon systems, there's lots of spatial variability in the stocks and carbon fluxes. That's really high. So that's the thing. How do we constrain that? One of the things we're looking at, we talked about remote sensing earlier, but we're looking at remote sensing of biomass and soil carbon using something that we call Carbon Watch. And basically what it does is it uses machine learning to build a digital twin of a site based on hyperspectral imagery. And that can be from a satellite, it can be from a drone. And from that, you can extract the morphological characteristics of the plant. So how tall are they? Um, and then you can apply allometric relationships that we have from literature for specific species to then get total carbon stocks. And this can differentiate among species. We've done it in other applications for invasive species monitoring and things like that. So it's a pretty powerful tool. And we can also couple it with a soil carbon model to get a total ecosystem stock. And then we can look at changes over time. Of course, this requires ground truthing, validation. It's absolutely critical, but at scale, this can be a lot more efficient than plot-based monitoring, where you need tons and tons and tons of data points.
Okay, I'm going to dig in just a tiny bit. For
Sure.
Blue Carbon Project, the kind of species, the carbon that you're looking at is there's mangroves, there's seagrass. I mean, just a tiny bit more precision on that would be super interesting. I think we're not all experts here. Um, I'm definitely not. That's why I'm asking. Um, and and in terms of ground truthing, actually, what works for blue carbon?
So it would basically be doing the on-site measurements per the methodologies that are required by your particular registry, your particular crediting mechanism. And so those are typically for biomass measurements. There's a plot base where you have to take so many diameters of trunks and things like that, and then you can either do actual direct sampling of the carbon in the plant tissues, or you can use, like I said, those allometric equations to then extrapolate out to the total plot. The soil sampling is it's just a soil core, and then you get the organic carbon that's sequestered in that soil. Simply put, that's how you do. And so those are your stocks. You can also do fluxes of gases in and out of the soil. In blue carbon, that's critically methane and nitrous oxide, because they're much more powerful greenhouse gases than CO2. So those are the kind of things you're doing. So remote sensing, we're not there yet with the gas fluxes. There you can do that remotely, but it doesn't give you the resolution and the concentration detection that you need for a natural system. You can do it for an industrial source, but it's just not simply there yet. So we're looking at that for the stocks. If we're going to look at the carbon flux or the gas fluxes in and out, we will have to use more traditional methods. But those, we're still trying to figure out exactly what the optimal, I guess, placement of the flux towers would be. And that's going to be something we work on with TASA, because they're going to be a critical partner in on-site measurement.
Cool. And food for discussion later.
Mm-hmm.
So we'll move on to the next section about stakeholder engagement like now, but you were saying something about scale that maybe I didn't want to cut off.
Oh, just that, we're looking, I mean, scale is kind of relative with blue carbon projects, and depending on what you're using to look at. So if we look at the total mangrove cover, it's like 5,000 hectares, which is a pretty decent sized site. The seagrass meadows are much, much larger, but they're a lot more challenging for the monitoring, and much more expensive to monitor, simply because you can't quite get the same quality imagery in deeper water and like you could for a terrestrial or a quasi-terrestrial system like mangroves. So we are focusing on mangroves first, and then starting to figure out how we can adapt our technologies with some of our other partners to more effectively manage the seagrass. But the whole idea is for this to be scalable up, because I think the next step after proof of concept and get some projects in the ground on Turneffe, there's a lot more mangrove areas that are under imminent threat on the mainland. And I think that is ultimately the end goal here, is to have a process that can be implemented elsewhere over much larger areas.
Amen. Okay, well, so now moving on to kind of the people it takes to mobilize these projects. I think, Jessie, that's more a question for you. How are you all engaging local stakeholders beyond the government and TASA? Who are the key players actually ensuring the long-term success of this project?
Yeah, so I know Jonathan talked a bit about our first stakeholder engagement meeting, which was that kind of boots on the ground initial opportunity when we were in Belize about a year ago, and that's really where things started. But our focus has always been ecological and social. I think we know for sure that a credible project that's going to have long-term impacts has to include co-development and co-design of the project. And for us, that means including local fishers, landowners, and other community-based organizations. Jonathan mentioned some of the great work that's already been done by scientists like Hannah Morissette. We hope to collaborate with her and several of the other NGOs that have already done some great work and research in the country of Belize. Universities and research institutions as well. The University of Belize has really done some fantastic work throughout the country, not only on blue carbon, but they have a really fantastic marine science program that we hope to get involved and also support. I know we're going to talk a bit more about TASA. Jonathan's mentioned them, this Turneffe Atoll Sustainability Association group. Their marine rangers are essential because of their history on the atoll. They're embedded in the ecosystem. They're already doing an incredible job managing the key resources that we're looking to support and develop.
That's amazing to have them. You also mentioned a stakeholder meeting that's coming up for the project. What are you going to be accomplishing there? Who's going to be involved?
Yeah, so a lot of the same groups that we worked with on this in this initial meeting will be in attendance, and several of the others that I just mentioned will also be included along with government officials. I think our hope is to involve some of the local community groups as well as the University of Belize, the Belize Fisheries Department, the Belize Forestry Office. I think the list will only grow in this next meeting, but the goal is to build on what we've already started in that first meeting. I think something that we've always said, and I think the reason again that gets back to this building trust, gaining trust, is spending a lot of time in these meetings listening and getting feedback so that this next phase of development is not only agreed upon, but that all of these different groups feel included and feel that they have a voice in the project and the process.
And that's a very specific set of skills, isn't it? And kind of like it's a subject that we also have, that we're starting working groups on in the collective. So, something to unpack in a total other NTC Now approaches to participation. But okay, moving on to the kind of specifics of a blue carbon project, or even more. How does that differ from more established nature-based solutions like reforestation? Not that you can compare, but is there something to say there of what's special?
Yeah, so I'll return to a couple of the same themes that I've already
Yeah.
spoke about a bit. Again, we were saying these are really dynamic systems. Again, complex geomorphology, biogeochemistry, and they're subject to some stressors we can't really fully control for. And so, sort of the classic example is, you can't just go and plant mangroves on a mudflat. That kind of stuff has been tried before, and that they're almost always doomed to failure. If mangroves are not present, if they were once there and now they're not, there's a reason. And so you have to understand what's wrong first, and then you got to figure out what you can do to make the site suitable for mangroves. It's really less about putting the right things there rather than just creating an environment that's conducive for them. And that can be a challenge, and sometimes it's very expensive to accomplish. So that's the first thing, is it's really making the site suitable for mangrove establishment and persistence. And the same for seagrasses, only it's even more complicated because you're underwater, and there's more stresses there. From a more blue carbon focus, we just said we've been talking about variability, and then blue carbon ecosystems typically have more variability in their carbon stocks and the fluxes of carbon, and that makes, like we've been saying, MRV challenging. And there's also permanence risks that you can't fully mitigate, even with careful project location selection and design, and that can affect both feasibility of the project and the credit yield. Both have to be considered when you're thinking overall project feasibility. However, these are really, really carbon dense ecosystems, and they're probably the best bang for the buck with just direct sequestration from the atmosphere and long-term storage of carbon for a natural system. And they've also got huge potential for co-benefits across a variety of sectors, whether that's coastal resilience, fisheries, biodiversity. We've said all these before. And they also have very well-established threats to them globally. So there's less issue with additionality and greenwashing that is sometimes problematic with more forestry-based projects, for example, especially looking at avoided emissions through avoided disturbances.
Fantastic. Yes, I'm seeing some comments pop up. Really comprehensive answers. Thank you so much. One of the things that I loved you mentioning at the beginning, and I think this was Jessie that said it to me, but first, this is supposed to be, I mean, it's the conservation versus restoration, right? You're planning it to be a conservation project, but for the moment it's a restoration project. Remind me what's happening here in that balance. How does that impact also the credit potential in the project design? Oh, sorry, Jessie, you're muted.
Thanks. I think one thing I can say about this pilot is we knew going into it that it was going to be more of a conservation project rather than a restoration opportunity, and that was okay. It was as a pilot study and for our needs, which was going to be, and for the government's needs, proof of concept, just to show what's possible. It was fine that we ended up with far more conservation projects than we did restoration projects. Jonathan, you want to talk a bit about how that impacts credit potential?
Sure. And that's one of the big things, this project, I mean, by nature, these aren't money makers, right? They're essentially, the way that these systems are designed is to pay for the project, to get the conservation stuff done. And that is especially evident when you look at a conservation project. And that's because when we're talking credit potential, restoration, just by the way the assumptions and calculations work, is going to be a higher yield option. You're starting from not exactly zero, but it's either a degraded or destroyed system, which has typically significantly impaired carbon stocks and potential to sequester carbon from the atmosphere. And so that's the baseline you're comparing your project to. So if you return a functioning blue carbon ecosystem and things go well, you have a massive bump in your credit potential simply because you're replacing something non-functional with something that is. With conservation, it boils down to the type of threats you anticipate for the site. So there's two kinds. You have planned and unplanned degradation. So with planned degradation, this is things that would require a permit or some sort of plan to do it. And the assumption is that someone's going to go in and develop a site with this planned degradation, and the whole thing is going to be, or most of it is going to be modified, destroyed somehow. And so if you protect your site from that happening, against that differential, and so if you were thinking that, okay, we're going to just bulldoze this entire thing versus leave it intact, that's a pretty big potential savings of emissions to the atmosphere. If you are looking at unplanned degradation, those are typically smaller scale, relatively speaking, kind of things. So it may be logging for firewood in a mangrove. It may be some sort of subsistence agriculture. It's typically smaller things that are under the radar, or sometimes it's natural impacts. And those are more like death by a million duck bites kind of things. And so you have to have, one, an established defensible risk, which sometimes takes a lot of background research, or you have to look at a regional or a local reference condition for losses. And that can be problematic because sometimes they're not directly applicable. Sometimes it's not exactly the same place. So you got to be very careful with how you defend that loss. All that to say is that the unplanned typically is a smaller impact. And so the differential between the baseline of that impact happening and your project protecting it is typically smaller than a planned degradation project. So it's usually a lower credit yield. So there's really kind of three tiers here. The planned degradation, the planned degradation is the high, or the restoration is the highest, because we're going from a known lost area to something functional. Then you have planned, where we're going to prevent that happening and keep it functioning. And then we've got sort of this incremental loss through the unplanned that we're preventing against too. So just by nature, restoration's a higher credit yield, but the atoll has such a large area that in some of these project areas, this conservation project actually can pay for the project with carbon credit revenues only.
All right, well, I look forward to a follow-up call in a few years to see how it's all doing. Okay. In some of the kind of like these last questions that we want to address together, and then I see the audience has a ton for you. You described a co-development model with the clients in general. How does this work in practice? Why is it valuable, Jessie?
I think one of the things that we noticed when we started Brightwater about 2 years ago and built this collective was this interest, I think, especially from some of the larger corporations, potential clients and investors in these high quality, high integrity projects. I think that for us, it was incredibly important to look at what their interests were when it came to, at the time, maybe not as much today, I'd say sustainability reporting as opposed to just ESG commitments. We'll say sustainability goals and commitments. What were they looking for and what goals were they trying to reach? We were seeing some visionary companies, in my opinion, come up with ideas for projects that actually included more than just a carbon credit. And that was really always our goal. So I feel like we felt it was really necessary to take that into consideration and to allow them this opportunity to co-develop or co-design a project. That's why we have worked to get to this stage with Stantec, for example, on this project, to get to the stage of a feasibility study. With that feasibility study, we have proof of concept. We have an understanding of which projects we would want to consider building out, designing first. But there's an opportunity for an investor or a client to co-develop and design these projects along with us to meet their sustainability goals or their cultural or social impact goals. We felt like that was one way to really meet some of the different standards and some of the different requirements that we're seeing from some of these clients and investors. And so far, it's proven to be very interesting to offer this menu of options and services. That's really one thing we didn't really talk a lot about, is this Brightwater collective that we've built, which Stantec is a part of. It allows our clients to come and almost kind of look at I don't really like the word menu, but menu of options when it comes to building out and designing a project that obviously is going to have specific standards built in, but is also going to allow a client to include things that meet their goals as well.
I'm so curious about what's on the menu. Can you give a few examples?
Sure. So I think we have some companies that are very interested in, let's say, cultural and community benefits, which is something that's very important to us. That will include looking at the inclusion of local and indigenous communities, which is really part of all of our projects, but maybe that's something that they really want to focus on or highlight as a result of their social impact goals within the company. Having an interest in some of the other, I like to call them co-benefits, core benefits, instead of co-benefits that some of these ecosystems provide. So maybe they're more interested in focusing on biodiversity. We have the ability to focus on that along with them. And even though, the biodiversity credit market may be still seen by some as nations, there's still opportunities to potentially stack those credits. So something that we're looking at considering within this pilot project. So I think that menu of options is something that becomes attractive to a client or corporation that's interested in going beyond credits, which is a big focus for Brightwater.
Mm. And hopefully we can, I mean, I don't think we have time right now, but I'd love to kind of get some even more detail on that and your kind of like what other ecosystem services you're measuring in general when we do the write-up of this.
Absolutely.
But for now, so what actually, I mean, we're going into this, what types of credits are you anticipating generating with this project? Which registries are you considering as well?
So we are, and Jesse, don't get angry with me for saying menu, but we are looking at a suite of options, shall we say. Um, we're looking primarily both at carbon and biodiversity for ecosystem services markets because those are the most developed. Although, there are coastal resilience type of things out on the horizon, so we're keeping our eyes on developing things. But from a market standpoint, we're focusing on carbon and biodiversity. Although, as Jesse was just saying, there are a number of investors who are looking just to do nature positive things for internal goals and objectives. And so we're definitely open to that too. And that's one of the reasons why we want to do that co-development thing is we want to meet what the investor needs, what they want. But specifically nuts and bolts, most of the carbon credits, as we were saying, is avoided loss of emissions, although there are going to be some restoration and direct capture credits available as well. Because it's largely conservation based, that is really putting us with Vera, specifically VM7, which was the RED plus methodology that then rolled in some tidal wetland stuff. It's the only one currently that I'm aware of that has a conservation of wetlands methodology. Restoration is going to be probably VM33, which is again is a Vera, but that's specifically for restoration of tidal wetlands. These are under revision right now, and most likely the modules from the RED methodology will be rolled into the tidal wetland. But that has been going on for almost a year now, and we're just kind of assuming that all that stuff will still be available when they're repackaged. We're just going to sort of navigate that as we get there.
Mm-hmm.
With biodiversity, we're looking at both stapling and stacking. And here's some jargon. Stapling would be attaching a biodiversity certification to a carbon credit to potentially increase its value. Stacking would be getting a separate biodiversity credit that could be marketed in conjunction with the carbon credit. So we looked at, again, Vera because they are dominant in this space. And so we looked at the Vera CCB, which is a certification you can add to it. That's probably applicable to these projects, especially when we start thinking about seagrasses and the associated coral reefs. The stacking Vera Nature framework has a separate biodiversity credit that we're looking at as well. That one's probably applicable here. And that would be something to think about when we think, maybe the carbon revenue isn't enough and we need a subsidy, or maybe there's, it's not the right thing for our investor. They want to focus on biodiversity. That's a way to do it. We also looked at Plan Viva, which they were a leader in the in the biodiversity markets. The issue with Plain Vivo is they are really focused on communities that are adjacent to or within your project area. And Turneffe is so remote, and the demographics of the few permanent residents, it doesn't really fit with Plan Vivo. But biodiversity markets, we're in early days here, so I think this piece of the puzzle is going to evolve over time. But I do think that we have a pretty good framework set up with the carbon crediting, and that's likely going to be sort of the roadmap to these other options because most of them are all set up on the same principles of there's baseline comparisons to a project scenario. There are, all the third-party verification. All these are similar ideas that just cascade throughout. So, adapting one to the other is not that difficult. It's just it gets down to, what are the specifics of the requirements to go to the registry, the specific calculations and things like that. But broadly, it's all relatively similar.
So appreciate the precision there as well. Thank you. Okay, we're gonna turn it to the audience Q&A, but before that, the last question is, I'm gonna put a two in one. Jesse, maybe you can kind of address that. how is this project going to inform the future of blue carbon development in Belize and beyond? And also, what's the call to action to the nature tech community here in general?
I think the goal of the project, being a pilot, is to establish, obviously, not only proof of concept, but to show, I think, what our real goal around all of these projects is that it's not about the carbon credit. It's about all of the benefits that these ecosystems and systems provide. Our goal is then to carry that forward, not only to other projects, as Jonathan mentioned, in the country of Belize and on the mainland, but elsewhere. I think there's still just too much of a focus on the credit itself and just the monetary value, and less of the focus that's needed on the actual systems. I think that's the other goal that we really have here at Brightwater Collective, is to not just focus on mangroves, but instead to look at system linkages, from the coral reefs to the seagrass beds, to the mangroves, to the wetlands. If we're not looking at the entire system, I think we're really missing it. And long term, if we can take what we're learning on Turneffe, take that to other places in Belize, and not only Belize but elsewhere, I think that will feel like we're successful. As far as sorry, what was the call to action? Thank you. I think just we are excited to, about this collective. I've learned so much from Nature Tech Collective. There's so many fantastic companies and organizations and people that are a part of this. We're very interested and open to other partnerships that'll help us to build on what we've already got going here, whether that's data tools, training, investment. I really believe that nature tech is one of the big keys to unlocking scalability here, and we really welcome others that share that vision along with us. So I would also just add and mention that Brightwater is in our seed funding round currently. So another call to action or out to the community is we are looking for investors in both the company Brightwater and in our projects themselves.
Excellent. And we will amplify. Jonathan and Jessie, thank you so much for sharing your process so deeply. We're now opening it to the audience. Audience, I am now allowing you to unmute yourself. I am going back into this kind of wall of faces gallery, encouraging you to, turn on your video and make this a cozy Zoom space. And gosh, there's so many questions. I'm just going to say we're not going to be able to cover them all. If you're a member, remember that you can speak to Jessie directly on Slack. But let's kind of go for this. VJ, are you still here? Is this VJ from Taking Root? And do you want to... No, it's not. It's VJ from Carbon Mint.
Yes, hi.
Hey.
Thank you for the presentation, Jessie. And so I'm very curious about two things, actually. In terms of the technology that Jonathan talked about, in terms of the hyperspectral imaging and what advances have happened. So if there's an opportunity to collaborate or really learn from what you've been doing there to really measure the biomass, that's one part. And then the second part is really if there are other opportunities to collaborate to see, if how these methodologies can be applied, commercially or otherwise in non-blue carbon projects as well. So maybe it's more of a discussion for another day.
Sure.
But I'm just, I heard from Jessie that you are open to those kind of conversations. So
Yes.
maybe you can put a few words, but yeah, please.
Yep. So the answer to both is yes. If you drop me an email, I can send you to the suite of watch technology. So we've applied it to a bunch of different things. Both in the nature sector and in the industrial sector, and it's not just carbon. There's all kinds of bits there. So yes, and I can put you in contact with Grant Wiseman. He's the lead for this. So yes, we definitely love to collaborate on these things.
Thanks.
Thank you.
Okay, now I'm seeing a question from J.A. Ginsberg. Did you want to voice that one out loud? going to go for no. Are there any other
Oh,
business
no,
models?
it
Sorry, go
was,
for it.
yeah. So there's a bunch of questions that all sort of revolve around credits and the viability of credits. So in looking at the geopolitical changes of the last few months, how has that impacted the market? And are there any projects out there in the world that you see, those are real role models, they've really got it together, this is really how this is moving?
So what I've seen from the market is a slowing of project development. What I'm hearing from everyone is we are still wanting to meet our commitments, but we're slowing the process a little bit. That is a little more prevalent domestically than it is internationally. I don't foresee much in the way of impact to carbon credit quality and anything like that. I think that particular hurdle has, I'm not going to say it's been leapt over, but we are seeing the market recover from a lot of the issues with greenwashing and things like that of a few years ago, particularly with a lot of the ICVCM and other quality metrics that have been in place. So I think that the carbon markets themselves have recovered from that, and I'm not seeing much depression in purchase or retirements of credits. A lot of that is because most of the big buyers are international, and they still have, regardless of what happens domestically, there's still a lot of commitments that have been made in the EU and other compliance markets, other voluntary markets that are sort of buffering that. I will say that we are involved in some projects in domestically where you might expect that to have and then geographies where you might expect there to be a major impact, and people are still pushing on, just thinking from long term that this type of stuff isn't going to go away. So long view is, we're keeping on track with our commitments, but in the short term, things have shifted around a little bit priority wise. I don't know if that answered the question very well.
No, it does, but it does raise sort of the question of, are there other things that you want to put into the mix? So in other words, the funding for this wouldn't be so reliant on carbon credits.
Yeah, absolutely. That I think gets back to this idea of menu or portfolio, because there's different investors who want different things. And so there's biodiversity, there's just sort of internal nature positive things. And then as things like coastal resilience come online, I think that's going to be a major driver. In my personal opinion, that is really going to be one of the drivers for this type of thing in the United States. Especially in the Gulf Coast, especially in Florida and the East Coast, we're already seeing a lot of impacts from sea level rise. I think if we can start looking at nature-based solutions and ways to implement potentially expensive and not as expensive as big old rocks in the ocean, I think that's really when a lot of this stuff's going to take off.
Okay, thank you. That's a business model. So thank you very much.
Great. Okay. Let's see. What question was next? A super quick one from Elsa about please sharing some links of Carbon Watch, if someone can in the chat, for example. And then Callie, good to see you. Width methodology, we've answered that, right? And then have you secured potential buyers? If not, who's the initial funder? What's the expected ROI for this project?
Sure. So we are in conversations with potential buyers currently, but because of the stage that we're in right now, which is feasibility, we've just completed the feasibility study for the pilot. So the next stage of design and development, I think, is where we'll really start to engage some of the clients that we have been talking to who are interested in these types of projects. I think we're, again, as Jonathan mentioned, it's the clients that are looking for more of that menu of options, who maybe for a project like this one that is more conservation focused and less about restoration. These are the clients who are, part of that ROI is actually the storytelling around the project. These projects have pretty incredible stories attached to them when it comes to biodiversity conservation and coastal protection, climate resilience. We do have some clients that we're in conversation with now who are just as interested in telling that story, investing in a project that tells that story as they are in the actual carbon credit.
Thank you, Jessie. Andrew, you also have quite a long question. Do you want to voice it out loud?
Sure. I guess kind of my hi, by the way, name's Andrew. I'm the CEO and founder of a company called Marnova. We're sinking carbon in the deep ocean using a novel macroalgae methodology. And kind of the question that I get, and I'm curious to get your guys' perspective. I also do work for the Navy in this standard blue carbon work, like looking at their mangroves and wetlands and stuff like that. And so my question is, right, there's a lot of variability in a lot of the process, especially when it comes to like trying to get carbon credits moving forward, right? So you have registries in and of themselves are very variable from one another. So there's studies done where people do the exact same project and go through like 5 different registries, and they end up getting anywhere between 100 to 400% variability in the terms of the amount of carbon that they are getting credited. Curious to get your opinion there on like how you guys are wanting to navigate the registry space, and then B, on like a kind of a more technical area, Jonathan, like, you know, the MRV is a huge topic, especially for those registries. And I know that models and things like digital twins and things are becoming added into the methods to be credited. But I'm curious to see how you guys measure or are accounting for any potential losses or that kind of variability that comes with not taking the sampling data and operating with a model or, you know, remote sensing and stuff like that.
Yeah. So, so the first one, yeah, I get you completely with how the registry varies with their calculations. And in my opinion is that there's a couple of major levers, especially with blue carbon, as to where that is. And it's what I've seen. It's usually methane flux. It's one of the big ones. And it's it's a lot related to data quality too. You know, when you have to default back to proxies and things like that, then I think that is one of the major things, which is pretty much directly what you said. But then, you know, how the various registries discount credit yields based on uncertainty, I think is probably some of that. So I would be surprised if there wasn't some shopping as to which registry people would go to based upon deductions that are in place just from structural standpoint. We typically navigate that with being as robust as we can with our data collection and the assumptions that we make. You know, we try to be as conservative as possible, just trying to get on the downstream end of that, or the lower end of that. And then when we get to the actual monitoring piece, we try to do as much, you know, keep our models as tight as possible within, you know, it's a balancing act of how much does it cost versus the you know, the amount you can constrain that variability. And it can get pricey in areas like this. So I think really the way that we do it is we try to keep it evolving and improving over time. I've kind of blended my second response into the first one. So sometimes the registry stuff is just, and it's not a very satisfying answer, but it just sort of, it is how they're structured, right? And so we just try to navigate that the best that we can. And in terms of how to get stuff, how to constrain that variability, how to, you know, improve the returns, you know, again, it's understanding things to the best that we can, making it conservative so we're not over-promising from what we can do. And then in your quote, one thing that, or the chat, one thing that I thought was really a good point to bring up is when we're burying carbon in sediments, it's not just this magical black box that just sucks it all up and it doesn't go anywhere anymore. There's that oxidized layer in the top, and there may be invertebrates mixing it up, and there may be respiration from all kinds of things happening. And so you're going to lose carbon out of that soil until it gets buried deep. And so one of the things that we're trying to do is not just say, okay, boom, this core, this carbon's in there in perpetuity. There's that top layer that we're going to lose some. And how do we quantify that? And one of the things we try to do with, we're looking to do, especially with Turneffe, is do some of the radiometric analyses so we can sort of see, where, at what depth do we see steady state carbon? And that is the true sequestration. That's what's actually being buried deep. And so there's some fraction of what gets in there that's going to be returned to the atmosphere. We have to understand that. So I think, there's base science to it. And then we haven't got to the point where we can train Carbon Watch to that yet, because we haven't applied it to blue carbon specifically yet. But we've done similar stuff with microbial interactions and terrestrial systems. I'm confident we can do it. It's just collecting that data and then training the model.
Amazing.
Well, thank you.
All right, well, we're slightly over time. I usually don't, but I'm inclined to give, the last question to Mark from CI if Jessie and Jonathan have the time.
Yeah,
Absolutely.
Yep.
Okay. Mark, did you want to peep out loud? Maybe not. Okay, then.
Excuse me. I have a quick question. There's so much focus on carbon. Is there any focus on measuring water cycle impact, since water is the most prevalent greenhouse gas?
So I think that's largely ignored for several reasons. I mean, water vapor does have climatic impacts, but like we just alluded to, that cycle is so fast, and we're not really, we're not directly affecting that balance. So I think it's really the anthropogenic greenhouse gases are the ones that and they have they've got a very long lifespan. Well, some have a very long lifespan in the atmosphere, and then that's really the focus. The whole 100 years for permanence thing is related to the behavior of CO2 in the atmosphere. Some of the other ones have less active lifespan in the atmosphere, if you will, but during that short term, they're much more powerful. So, we have to scale them up with a greenhouse warming potential and things like that. But a lot of that stuff is either directly or sort of indirectly caused by humans, and so that's really where the focus is. So water vapor, you're right. There are some effects there, but they're not really considered because it's not exactly the problem we're trying to fix, if you will.
All right. Okay. Well, we'll end it there. Mel, I see you have a question. I'm going to let you ask that in the Slack, Jessie. Oh, Mark, okay. Exactly. You're also a member of the collective, in case you didn't know, CI. So feel free to join the Slack. And that's my general message is thank you so much to Jessie and Jonathan. We will be posting this recording online. We will be sharing also a blog post about it on our newsletter or on our LinkedIn as well. So those are also places to continue the conversation and ask all those questions. So thankful for the depth of the expertise and your time sharing it. Thanks, Jessie and Jonathan. Thanks, audience, for being here.
Thank you.
Yep. Thanks everybody
for having us.
Mm-hmm.
We appreciate it. Have a good day.
Have an amazing day, evening, afternoon, everyone.
Wherever.
Bye.
Thanks, Paige. Bye-bye.